Okay. Is it the screen is visible to all?
Yes, sir.
Okay. So in the previous lecture we seen that one theorem. So there is a mistake happen in the previous lecture. Okay, what is that mistake? Look at here. Let K be an extension of F, then A belongs to K is algebraic over F if and only if F of A is finite extension of F. Okay, what is the mistake happen here? Hmm. Look at here. In first part, if part, let us assume that F of A is the finite extension of F. Okay, so degree of F of A over F M, that is finite. We have to prove that the A is algebraic over F. Okay, so here let f of a over f, degree of f of a over f is m, and f of a is what? The field, and a belongs to f of a. So here 1 a square a cube up to a raised to m belongs to f of a. Why? Because f of a is the field and a belongs to f of a, and by using the property closure under multiplication, these all the elements are belongs to f of a. Okay, these are m plus 1 elements in f of a. Okay, and dimension of f of a over f is m. Okay, the dimensions of f असेल, so these m plus 1 elements of f of a are linearly dependent पाहिजे. Okay, हे mistake झालं. Linearly independent नाही आहे. Okay, त्या वेक्टर स्पेसची डायमेन्शन किती आहे m आहे, आणि मग जर m डायमेन्शन असेल तर त्या लिनियरली इंडिपेंडेंट सेटमध्ये जास्तीत जास्त m एलिमेंट्स मला मिळतील. तर m प्लस 1 एलिमेंट जर असतील तर ते कसे असतील? लिनियरली डिपेंडेंट. ओके, सो देन जर लिनियरली डिपेंडेंट असेल तर काय होणार? ऍटलिस्ट हां, जर लिनियरली इंडिपेंडेंट असेल तर काय झालं असतं? तर हे ऑल द कोएफिशिएंट्स आर कसे असते असते? 0. Okay, since these are the m plus 1 elements of f of a are linearly dependent, it means that the b naught, b1, beta 2 up to beta m, bm belongs to f, not all zeros. Okay, there is zero येणार नाही. Okay, hence b naught plus b1a plus beta 2 b2a square up to so on bm a raised to m is equal to 0. Not all the coefficients are 0, hence a satisfies the non-zero polynomial f of x. Okay, फक्त काय मिस्टेक झाला होता इथे? लिनियरली डिपेंडेंट असायला हवा होता, नॉट इंडिपेंडेंट. ओके, तर ते काल जरा मिस्टेक झालं तेवढं हे करत. Okay, so we seen that in the previous lectures, let A be an extension of f and A belongs to K is algebraic over f if and only if f of A is finite extension of
सर
f.
काही प्रयत्न जॉईन होता येईना.
Hello,
हॅलो सर, काही स्टुडंटना जॉईन होता येईना सर.
काही स्टुडंट्सना जॉईन होता येत नाही. ओके, वेट. 31 स्टुडंट आहेत ना प्रेझेंट. Okay. Okay. So we will say we seen that the every finite extension is algebraic extension. Okay. If जर एखादा एक्सटेंशन जर algebraic extension असेल तो if and only if तो काय असेल? Finite extension. Okay. Now the some remarks are there.
सर सफिशियंट पार्ट मध्ये एलिमेंट्स लिनियर इंडिपेंडेंट असणार का?
हा, लिनियरली इंडिपेंडेंट असते. हा, इथे ना
Yes,
इथे
sir.
n एलिमेंट्स आहेत, नॉट n प्लस 1. ओके, 1 आणि अप टू n मायनस 1 आहेत ना इथे, त्यामुळे ते इथे काय असणार? लिनियरली इंडिपेंडेंट. इथे m प्लस 1 होते. ओके.
Okay, sir.
Some remarks are there. Okay. What is the remark? If okay, degree of f of a over f. Okay, that is the dimension of the vector space f of a over f is equal to m. So m असेल. Okay, and A is algebraic. A is algebraic over capital F. Okay, now let the degree of A over the field F be n. Okay, so n असेल. What is the meaning of this sentence? A satisfies the polynomial of degree n. Okay, then we have the degree of f of a over f. A ची डिग्री जेवढी असेल त्याची किती असणार याची डायमेन्शन सॉरी n. Okay, so this implies m is equal to n. हा m आणि हा n कसे असतील इक्वल असतील. Hence the degree of f of a over f is equal to m, then a is algebraic. A is algebraic of degree m over f. A is algebraic of degree m over f. ओके, म्हणजे या एलिमेंटची डिग्री, या अल्जेब्रिक एलिमेंटची डिग्री जेवढी असेल तेवढीच डायमेन्शन कोणाची असेल एफ ऑफ ए ओव्हर एफ. ओके, सो दिस इज द नियम. ओके, एनी डाउट?
No, sir.
Okay, the next theorem is every finite extension k, every finite extension k of a field f f is algebraic. Okay, every finite extension of k over the field f is algebraic extension आहे, हे प्रूव्ह करायचं. Okay, proof. Suppose k is a finite extension of f. K is a finite extension of f, capital F. Then finite extension म्हणजे काय असेल? Then k will be an algebraic extension of f, an algebraic wait a minute, लाईट गेली त्यामुळे अडचण. Okay. Now the screen is visible to all.
Yes, sir.
Yes, sir.
Suppose K is the finite extension of F, then K will be algebraic extension of F, algebraic extension of every element of K. Okay, every element A in K is algebraic over F. Okay, K will be algebraic extension of F if every element A belongs to K is algebraic over F. Okay, what is given to us? K is the finite extension of F. Okay, if K is the finite extension of F, then let degree of K over F is what? Finite. See, same. Okay, what is given to us? The finite extension, every finite extension K. Okay, so here K is the finite extension of F. This means the degree of K over F is M. Okay, which is finite. So we have to prove that this extension is algebraic extension. That means every element A belongs to K is an algebraic over F. Okay, now since K is a field, K is a field. Okay, and A belongs to K. Therefore, the M plus one element, the M plus one elements, which one? One, A square up to so on, A raised to M minus one, and A raised to all are in K. Okay, any doubts? The A belongs to K, the cell, the M plus one element gas are all are belongs to K. Okay, now since the dimension of vector space, the dimension of vector space K over F is what? M. Therefore, these M plus one element, these M plus one elements are linearly dependent. Okay, these M plus one elements of K, capital K, are linearly dependent. Okay, over field F. Any doubts up to here? Okay, so therefore, this implies
No,
there
sir.
exist there exist there exist the coefficients alpha naught, alpha 1, alpha 2, alpha 1, alpha m, all are belongs to F, not all 0. Okay, a constantly definition. This is the definition of linearly dependent. So there exists alpha naught, alpha 1, alpha 2, up to so on, alpha m, all are belongs to F, not all 0, such that alpha naught into 1 plus alpha 1 into A plus alpha 2 into A square plus up to so on. Alpha m into A raised to m is equal to 0. Okay, so this implies just linearly dependent असते तर काय independent असते तर काय झालं ते जर तुमचा आपण linear combinations जर 0 घेतला तर ते काय होईल automatic all the coefficients are 0 but here the linearly dependent these vectors. It means these all the coefficients not all 0. Okay, so here A satisfies okay the non-zero polynomial, a non-zero polynomial. Okay, which polynomial? P of x is equal to alpha naught plus alpha 1 x plus alpha 2 x square plus up to so on alpha m x raised to m. Okay, all the coefficients alpha naught, alpha m, alpha 2 all belongs to f. This means that p of x belongs to f of x of degree at most m. Okay, so this implies a is algebraic over f. Okay, therefore, hence capital K is an algebraic extension of f. Algebraic arbitrary element है ना कौन था ये? A is the arbitrary element of K. So every element of K is algebraic over F. Then hence K algebraic extension of F. Okay. So hence we can say that the every finite extension is an algebraic extension. Okay. Any doubt? Now one more remark
No,
is
sir.
there.
No, sir.
Which one remark? If the degree of K over F is equal to m. Okay, then each element A belongs to K. हा finite extension झाला. Finite extension म्हणजे काय झाला? Each element A belongs to K is algebraic. Okay, algebraic over yeah. Okay, but this K is algebraic extension of F. It means that every element A belongs to K is algebraic over F, and the degree of A over F. Okay, the degree of A over F will be at most M. Okay, समझ if degree of K over F is equal to M, then each element A belongs to K is algebraic over F of degree, and the degree of A over F will be at most just किती असेल M. कमीत कमी M पेक्षा खाली असेल. For example, look at it. K is equal to Q root 2. Okay, and if F is equal to Q, what is the degree of this one? 2.
2.
Okay, म्हणजे काय या हा जर तुमचा Q असेल, ओके, आणि हा काय समजा तुमचा Q root 2 असेल. ओके, या Q root 2 मधला कोणताही एलिमेंट जर घेतला, ओके, त्याच्यात त्याची डिग्री किती असेल पाहिजे ॲट मोस्ट m. ओके, नाव इकडे A is equal to root 2 belongs to root 2. Okay, so what is the degree of A here? Let x is equal to root 2. Here x squared minus 2 is equal to 0. Okay, so degree of A is equal to root 2 is equal to 2 over Q. Okay, now A is equal to suppose 2 percent. Okay, and this is belongs to Q root 2. Okay, what is the degree of this element A? Let x is equal to what? 2. So this implies x minus 2 is equal to 0. So here the P of x is equal to x minus 2. This belongs to Q. Okay, so what is the degree of 2 is 1. म्हणजे at most किती असणार 2 असणार.
1.
2 पेक्षा खाली असेल किंवा 2 असेल, पण 2 पेक्षा जास्त नसतात. ओके ओके, एनी डाऊट?
No,
No,
sir.
sir.
The next theorem is let capital K known an extension of field F. Extension of statement fixed है वर्ग the theorem. Let capital A be an extension of field capital A. Okay, and A1, A2, A3 up to so on AN. These are all the elements B and elements in K. Okay, capital K. And which are algebraic. Algebraic over capital F. Then F of A1, A2 up to so on AN. Okay, is finite extension of capital F. ओके, हा काय तुमचा फायनाइट एक्सटेन्शन हा प्रूव्ह करायचा आहे. अँड कॉन्सिक्वेंटली अँड अल्जेब्रा, तो काय दाखवायचं आहे, अल्जेब्राइक extension of the field F. Okay, what is theorem says? Let K be an extension of the field F. And A1, A2, A3 up to N be the N elements belongs to K, then which is algebraic over F. Then the F of A1, A2, An. This finite extension of F, and every finite extension is algebraic extension. Okay, आधी तर theorem मध्ये एकच element होता F of A. Degree N elements. Okay, so look at this. We have what we have. F is contained in F of A. It's contained in F of A1, A2, A1, A1, A2, which is contained in up to so on. Okay, F of A1, A2, up to so on An, which is contained in K. Okay, what we have to do? This extension of F is the finite extension. That means degree of F of A1, A2 up to so on N over F. Finite. Okay, we have to do that this one. F of A1, A2 up to so on An over the field F. Okay, algebraic over F मतलब ना. Okay, finite extension का मतलब of F मतलब higher वाला is equal to finite. Finite. Okay. Now we have F is contained in F of A1, is contained in F of A1, A2 up to so on F is contained in F of A1, A2 up to so on An, which is contained in K. Now since AK कोणताही एक आर्बिट्ररी एलिमेंट आहे बरं, तो A1 आहे, A2 आहे नाही माहिती मला, आर्बिट्ररी एलिमेंट घेतला या एलिमेंट मधला n एलिमेंट्स. ओके, सिन्स AK is algebraic, n elements algebraic. Okay, so here AK is algebraic over F of A1, A2 up to so on An. Sorry. Since AK is algebraic over F, A1, A2, A3, An. These are the n elements in K with algebraic over F. Okay, we have taken here any arbitrary element ak is algebraic over the field F. Okay, therefore, therefore, it is also algebraic over f of a1, a2 up to so on an. Why? Because this f is contained in what? F of a1, and f of a1 is contained in f of a1 to okay, a1 a2. The ह्याच्यावर algebraic असेल तर ह्याच्यावर automatic algebraic होईल. Okay, why? Because f is the subfield of f of a1 a2 up to so on an. Okay, so since here the AK is algebraic over F, therefore it is also algebraic over F of A1, A2 up to so on AN. Wait a minute, AN है ना, AK minus 1. Okay, AN minus 1. Okay, so now with the A is equal to 2, A2 is algebra over pi F of A1. Okay, A3 is algebraic over F of A1, A2. आधीच्या फील्डमध्ये. ओके, मग हा algebraic केला तर हा मग ह्याला करावा. मग हा A4 is algebraic over F of A1, A2 and A3. Okay, similarly here the AK is algebraic over F. It means that it is also algebraic over F of A1, A2 up to so on AK minus 1. Okay, any doubt? Okay, F for the algebraic
No,
असेल
sir.
तर हा F कशात contained आहे F of A1 F of A1 पण contained आहे F of A1 A2. Okay, F of A1 A2 is contained in F of A1 A2 A3. Okay, so हा 3 असेल तर कशावर येईल algebraic over F of A1 A2 ह्याच्यावर येईल ना. हा तुमचा A3 इथे आहे F of A1 A2 A3. A3 ह्याच्याकडून 3 असेल so F of this A3 is algebraic over previous field वर येईल ना त्याच्या. Okay, so hence the AK is algebraic over F. Then it is also algebraic over F of A1, A2, so on, AK minus 1, which is the superfield of F. Okay, superfield of capital F. Because any non-zero polynomial over F is also non-zero polynomial over F of A1, A2, up to so on, AK minus 1. Okay, yeah, F was also non-zero असेल तर F of A1, A2, up to so on, ह्याच्यावर तुमचं कसं असेल non-zero. Now, AK is algebraic over F of A1, A2, up to so on, AK minus 1. Okay, so this implies, okay, this implies F of, look at here, A1, A2, up to so on, AK minus 1. Okay, या फील्डला काय जॉईन केलंय मी आता AK जॉईन केलंय. Okay, F of A1, A2 up to so on AK minus 1, join that element AK to previous field. Okay, is finite extension of F of A1, A2 up to so on AK minus 1. Okay, या आधी या फील्डला काय जॉईन केलं मी AK. तर एफ हा काय असेल तुमचा फील्ड असेल आणि एचा हा अल्जेब्राइक ओव्हर एफ असेल तर आपण काय करतो एफ ऑफ ए काय म्हणतो फायनाइट एक्सटेन्शन. ओके त्याचप्रमाणे इथे काय एफ ऑफ ए वन ए टू अप टू सो ऑन ए मायनस वन इज फील्ड. ओके एफ च्या ऐवजी काय फाईव्ह ए च्या ऐवजी काय फाईव्ह. ओके त्याला ओके so here f of a1 a2 up to so on ak minus 1. So this field is a finite extension of this one f of a1 a2 up to so on ak minus 1. Okay, what is the reason? If a belongs to k, it's algebraic. Algebraic if and only if f of a is finite extension we proved in the previous lecture. Okay, so this implies f of a1 a2 up to so on ak minus 1 and this one is ak. Okay, this finite extension of f of a1 a2 up to so on ak minus 1. Okay, हा म्हणजे काय म्हणजे फाईल. Okay. Okay, so here this is the finite extension of this field. So this implies the degree of f of a1, a2 up to so on ak minus 1 and ak over f of a1, a2 up to so on ak minus 1. It is degree finite. Suppose it is lambda. Okay, any doubt up to here?
No, sir.
Okay, so by the transitivity of extension, finite extension, we have one theorem. Okay, and the f is the extension, k is the extension of f, and L is the extension of k. So this implies the degree of L over f is equal to degree of k over f. Okay, into degree of L over k na. Degree of L over k into degree of k over f by transitivity of finite extension. Okay, so use that transitivity here. So we get the degree of f of a1, a2 up to so on an over the field f is equal to degree of f of a1, a2 up to so on an. Okay, over f of a1, a2 up to so on an minus 1. Okay, हा याचा काय फील्ड आणि हा याचा सुपर फील्ड आहे. ओके, इनटू degree of f of a1, a2 up to so on an minus 1. हा कोणाचा सुपर फील्ड आहे f of a1, a2 up to so on an minus 2. Okay, up to so on into we get f of a1 is over f. Okay, any doubt?
No, sir.
Okay, by the transitivity of finite extension. So this implies the degree of f of a1, a2 up to so on an over the field f. Okay, by this step. In general, we prove this one for k. Okay, for ak. Actually, degree किती येईल मग? इथे लॅम्बडा k असेल तर किती येईल? लॅम्बडा n. Okay, into actually degree किती येईल? Lambda n minus 1. Okay, we have lambda n minus 1 into lambda n minus 2 up to so on lambda 2 into lambda 1. Okay, this all these lambda are finite. Hence, the product of this all one is also finite. Okay, but since each lambda k is finite, f of a1, a2 up to so on an over the is is the finite extension of capital F. Okay, and we know that every finite extension is algebraic extension. F of a1, a2 up to so on an is algebraic extension of F. Okay, by previous theorem. Which one? This one. Every finite extension K of a field is algebraic extension. Okay, so hence we prove that the field be an extension of the field F, and A1, A2, A3 are and An with the n elements belongs to K is algebraic over F. Then F of A1, A2 up to An is a finite extension of F. Okay, and finite extension, you know that every finite extension is algebraic extension. Okay, any doubt?
No, sir.
Okay. लिहून घेताय का काही काही राहिलंय का नाही okay so we will move towards this next point. The next theorem is next theorem is look at the statement. Let capital K be an extension. Capital K be an extension of a field capital F. Then the elements in K which are algebraic over F form a subfield of K. Okay, so in other words, we can say that in other words, if A and B belongs to K, okay, algebraic element over the field F, then prove that A plus minus B, okay, A into B and A divided by B such that B is not equal to 0, okay, are all algebraic over F. What is statement say? If K be an extension of the field F, then the elements K, elements in K which are algebraic over F forms a subfield of K. म्हणजे असा एक collection घ्यायचा set of collection which are all the elements from K and algebraic over F. They form the subfield of K. Okay, so काय करतोय subfield तयार करतोय. म्हणजे त्याचा अर्थ काय? In other words, we can say that if M belongs to an algebraic over F, then we can say that A plus minus B, A into B, A divided B, A by B, all are algebraic. Okay. म्हणजे तुम्हाला समजा root, okay, it's algebraic over q3. Okay. Root 3 is also algebraic over q. Okay. So root 2 is root 3 is also algebraic over q. Okay, म्हणजे एक्झामला काय करतात, हे तुम्हाला स्टेटमेंट माहित नसेल तर काय करतात, which of the following is algebraic over 2? root 2 आहे, root 2 plus root 3, root 2 minus root 3, root 2 divided by root 3, all of the above असे विचारतो. डायरेक्ट नाही विचारणार ते क्वेश्चन, तुम्हाला कुठलं तर प्रॉपर्टी यूज करून ते विचारणार. ठीक आहे. So here the let with the k be an extra pattern. The elements in the which are algebraic over f, they form the subfield of it. Okay, याचा अर्थ काय, a plus or minus b, a into b, a divided by b, this not equal to 0, all are algebraic over f. Okay. Now, look at that proof. Okay, let set a is equal to a belongs to k such that a is algebraic over f. Okay, we have to prove that the collection of all the elements belongs to k, which are algebraic over f, forms a subfield. That is, we have to prove that capital A is subfield. Okay, subfield of k. Okay, the subfield of k is कोणत्या दोन कंडिशन प्रूव्ह करावं लागते, a minus b belongs to k and a into b belongs to k. हे दोन मला
A B inverse Q.
कंडिशन दाखवायला लागते. Now consider a and b belongs to a. Then a and b belongs to काय असतील, k असतील. हे हा एक आहे तुमचा सबसेट आहे ना आता k चा. तर या a मधून येत असतील म्हणजेच काय k मधून येत असतील. ओके, a and b belongs to k and are algebra over f. This one is algebraic over f. A and b are algebraic over f. Since b is algebraic over f, capital F, this implies capital B is algebraic over f of A. Why? Because f is the subset of the field of f of A. Okay, this is that f of A is superfield of f. Okay, that we have algebraic over f, so that B is algebraic over f of A. So this implies the previous theorem, f of A join this field, the element B, which is equal to f of AB. Okay, is what? Finite extension. Okay, finite extension of f of A. F of AB is the finite extension of f of A. Okay, now by the theorem, which theorem? The previous theorem. If A belongs to K, okay, if A belongs to K, it's algebraic. Okay, if and only if f of a is what? Finite extension of f.
Finite extension.
Okay, if and only if the high character says the high to hold, the high character says the high to hold. Okay, we say that the f of a b is the finite extension of f of a. Okay, so this means that f of ab over f of a is finite. Okay, by this theorem, f of ab is simple. The degree of f of ab over f of a, okay, is finite. Finite extension is the degree of the finite. Okay, so this implies also f of a over f dot over finite. Similarly for the n element a, since what is a is algebraic over capital F. Okay, now by the transitivity rule, f of ab over f is equal to f of ab over f of a into f of a over f, degree of f of a over f. I is finite, I is finite, then the one sub finite. Okay, so this implies f of AB is finite extension of f. Okay, now every finite extension is what? Algebraic extension. This means f of AB is algebraic extension of capital F. Okay, what is the reason? Every finite extension is algebraic extension. Okay, so here f of AB is algebraic extension of F. Now f of AB is a field. Okay, and transfer f of AB हा field असेल, A and B belongs to F of AB. Okay, तर field असेल तर तो काय असेल? Additive subgroup असेल, additive group असेल, okay, commutative group. This means A minus B also belongs to F of AB. Any doubt? F of AB is what? Algebraic
No,
extension
sir.
of F. Okay, so this means A minus B belongs to A minus B is belongs to AB and f of AB is algebraic extension of f. म्हणजे याच्यातलं प्रत्येक एलिमेंट काय असणार? अल्जेब्रिक असणार. कोणावर? या एफ वर. आता A मायनस बी हा काय बिलॉंग्स टू ह्याचा एलिमेंट आहे त्या फील्डचा. दिस इम्प्लाइज A minus B is algebraic over F. Any doubt?
No, sir.
Okay, so this implies A minus B कशात जाईल माझा? Belongs to A. Okay, give it an equation number 1. Now, if we have to calculate the second one, A B inverse belongs to A. Okay, if A and the non-zero B belongs to A are algebraic over F. Okay, ए कशाचा आहे माझा एफ ऑफ ए बी मध्ये, बी कशाचा आहे एफ ऑफ ए बी, म्हणजे एफ ऑफ ए बी काय माझा फील्ड आहे, म्हणजे काय असेल एफ ऑफ ए बी बिलॉंग्स टू एफ ऑफ ए बी. ओके, ए हा काय बिलॉंग्स टू एफ ऑफ ए बी. Non-zero b also belongs to f of a b, and f of a b is what field. It means that a b inverse also belongs to f of a b. Okay, but f of a b is what algebraic extension of capital M. Okay, this implies a b inverse belongs to a. Number 2. Okay, so from 1 and 2, A is subfield of capital K. That is, the elements. Okay, the elements in K which are algebraic over F. Okay, which are algebraic over F forms a subfield. Okay, any doubt? Okay.
No, sir.
This is step number 1. Step number 1. Okay, and step number 2, we have to do that a plus minus b, a into b, okay, divided b, all are algebraic. Okay, and step number 2. To prove that a plus minus b, a into b, a divided by b is not equal to 0 or algebra over F. Okay, now as f of ab is a field, as capital F of ab is field, okay, which contains both F A and B. Both F, yeah, F of A मध्ये काय काय करणे असेल F A and B. Okay, and A and B belongs to F. This implies, sorry, F A and B belongs to F of A B. Okay, so this implies A plus B, A minus B, A into B. Okay, and inverse, that is A divided by B, B is not equal to 0. All of the elements belongs to what? F of AB. Okay, but f of AB is what? Algebraic extension of F. Okay, why? Because f of AB is finite extension of F. It means f of AB is algebraic extension of F. It means every element of this field is algebraic over F. So here A plus B plus minus B, A into B, A divided by B, B is not equal to 0 are algebraic over F. Okay, so this is the proof of the theorem. Any doubt up to here? ओके, सगळे
No, sir.
थेरम पाहिल्यानंतर घोळ होण्याची शक्यता आहे. ओके, सगळे थेरम एकसारखेच दिसत आहेत. फायनाइट एक्सटेंशन, अल्जेब्रिक एक्सटेंशन, degree of an extension, degree of an element, algebraic element. Okay, wait a minute.